In this video, I will show you how to create some job files to cut this sign on the Smart Bench. We will be using Vectric for CAD/CAM, and the toolpaths will include engraving the text, mounting holes, and contour of our sign. We will be cutting our sign from the 12mm thick plywood. We will set the Z datum at the bottom of our material, and we will use 2 tool changes to achieve this. Let me start by showing you how to define the job setup in Vectric. This video will show you how to define a job setup in Vectric. You start from creating a new file by clicking on Create a new file. For the purpose of this tutorial, it will be a single-sided job, so we need to select single-sided. The units we will be operating are millimeters, so we select millimeters. And now we can define the job size, which will be 600 millimeters along the x-axis and 400 millimeters along the y-axis. And the thickness of our material is 12 millimeters. We will be defining our Z0 position at the machine's bed. And the bottom left corner of this rectangle will be our X and Y datum position. So the point here will be the closest point to the console on the Smart Bench. Now we can define the modeling resolution, which we use as standard for faster performance. And here we will select, for example, Birch. So now when all the settings are updated, we can click on OK. And now this is a good moment to save our file. Please find a location for your file where you want to save your job. I will create an additional folder here, and I call it first routing project. And now I'll save my file as my first project. So now we set up our job and we can draw the features we will use in our routing job. We will start from the rectangle, which will define the contour of our sign. And we will do a parametric setup of the rectangle. We will set up anchor points with x and y equals 10s. And we will do curved corners with the radius of 10 millimeters. And because our sign is 600 by 400, we will just make sure it is within the boundary, and the offset from the edges is 10 millimeters. So now we can create this rectangle. As you can see, it has appeared here with the equal distances from the edges. We now can close this window. So the next feature will be our mounting holes. So we'll go and draw the circle. And the diameter of the circle will be 7 millimeters. And we again use parametric values to position our holes at the particular locations. So this is our bottom left. So we will keep X at 30 millimeters. And we'll go and create another hole in the top left corner. Now we need to adjust the X to be 570. Create our bottom right corner and our top right corner. Now close. And the last feature we need to create is our text, which will be written on the sign. We will write my first project. We will make sure that the text is aligned in the center, and the text height is 72 millimeters. Don't worry about the position in the text. There is a special feature in Vectric allowing you to position the text in the middle of your job. And to do that, you need to make sure the text is selected, so its appearance changes to magenta. And you can go to Edit, Align, Selected Object, and you can specify it needs to be positioned in the center of your material. Don't forget to save your file. And now your job is ready to produce the cutting toolpaths. To generate a cutting toolpath, CAD/CAM software will use the drawn features and the tool settings saved in the tool database. So the first thing to do is to check whether we have all the tools required to do the job in our tool database. You can go to Toolpaths, Tool Database. In this particular job, we will be using two types of tools. We will be using an engraving tool and we'll be using a flat-end mill. By checking in the engraving section, we can see that the tool we will be using is missing, so we will need to set it up. There are two ways to set the particular tool. You can do it from a particular toolpath generating, or you can go to Toolpaths and Tool Database and add the tool in this list. So Vector Database arranges the tool by material, and you can also create several tabs just for better sorting and better visibility. We're using soft plywood, so we will set up a tool by selecting softwood from the menu. We will go into engraving tools and we click on this plus sign to add a tool. The tool type will be engraving. The units used millimeters. The shank diameter is 6.35 millimeters, but we will be using a 90 degrees engraving tool. But beware that the side angle is just a half of the angle, so therefore we will put 45 degrees in here. And number of flutes for our particular tool is 2. So now we can create settings for our tool by clicking on Create Settings. We will set up pass depth as 2 millimeters. Step overs are not relevant because we will be doing a contour engraving, so we can disregard. We can just ignore these settings here for now. Spindle speed we will leave at 20,000 RPM. Feed units will be millimeters per minute. Our feed rate will be 3,000 millimeters a minute, and the plunge rate 750 millimeters a minute. It's worth keeping in mind that the selected parameters are just the nominal values, and these will depend on the type of tool you're using and the type of material you're using. So you can refer to our knowledge base article on feeds and speeds. So we can click OK, and it will save the tool in our database. So now we can check the tool is now present here. And the second tool we're using is just a 6mm end mill, which is already set up in the database. If you don't have the tool in the database, you can set it up the same way as we set up the engraving tool. Now all our features are drawn and tools specified in our tool database. We can start generating cutting toolpath by assigning a tool to particular features. We will start from engraving the text. So you need to select the text. Its color will change to magenta, showing you that it is selected. Click on the Toolpaths tab. You can pin it so it doesn't hide itself. And we can go into Quick Engraving Toolpath. We need to select the correct tool, which is Engraving 45 degrees side angle tool. And check the parameters for spindle speed and feed rates and plunge rates, which appear to be correct for our particular job. And clicked on Select. Our engraving will be 2mm deep. We will do just outline of the text. And the only thing is left is to choose the post processor. And Yeti Tool Smart Bench post processor exists in Vector Database. So we need to choose it. And once all parameters are set, we need to click on Calculate. Our quick engraving toolpath appears in the list, and our 3D view tab shows you the preview of the toolpath. Now we can continue generating toolpaths. We can close this preview toolpath window. The next step we will do is our mounting holes. Start by selecting the first hole, hold Shift button on the keyboard, and left click on all circular features here. The color will change to magenta. That means they're all selected. We will use the pocket toolpath generation tool. Because we need to cut through the whole depth of the material, and our material is 12 millimeters thick, we will need to go a little bit deeper than 12 millimeters. So therefore our start depth will be 0 millimeters. Our cut depth will be 12.5 millimeters, which is half a millimeter deeper than the bottom surface. We now need to select the correct tool, which will be end mill 6 millimeters. And again, check our feeds and speeds for the particular selected tool, which appear to be OK for our job, and click on select. Now we need to edit the number of passes, which defines how deep the cutter goes into the material on every pass. Vectric normally defines it automatically, but you can override it with the desired number of passes. In this particular case, we will choose 5 passes, which will make each path 2.5 millimeter deep. Don't forget to click on Set Passes so it will change in the list, and click on OK. Because we're cutting 7 millimeter diameter holes with the 6 millimeter tool, we can use an offset cutting rather than raster cutting. And we can choose the cut direction as climb. Once all parameters are set up, we can click on Calculate. There will be a warning saying that we are cutting through the depth of the material, which is correct. So we can confirm that. And once again, our toolpath will appear in the list, and its preview will appear in 3D View tab. Now, the last but not least, we need to specify the tool and the method of cutting our contour for the sign. Close our preview toolpath window. Click on our contour toolpath and choose the profile toolpath from the list. Once again, we will be cutting through the whole depth of the material. So that means we need to go a little bit deeper than that. So our starting depth will be 0, and our cut depth will be half a millimeter deeper than the thickness of the material. We need to select the correct tool, which is our 6 millimeter end mill. Click on Select. We will be cutting on outside of our contour, so our sign will be the size of our contour. And because once the tool cuts through the depth of the material, the sign will detach itself from the stock material. This is what we don't want to happen, and we can say that we need to add tabs. If the locations for the tabs are not satisfactory, you can always go and edit the tabs. You can delete the tabs shown, and you can say how many tabs you want to add. Let's assume that we want 2 tabs on each side of the rectangle. So we'll put number 8. And Vectric will automatically assign to the best of its knowledge, taking the placement parameters into account, and it will display the preview of the tabs. If everything is good, you can close. If you want to define the depth of each pass, you can click on Show Advanced Toolpath Options, and you can edit number of passes here. We will apply the same logic as we did with mounting holes. So we will do 5 passes at 2.5 millimeter depth each. We can set the passes now, and we can click OK, And after all the parameters are set up, we can click on Calculate. Once again, the warning will come up about cutting through the whole thickness of the material. This is OK for us. We can confirm our choice. Now, if you want to see the preview of all the toolpaths, you can click on Toolpaths in the list, and it will display you all the toolpaths set up for this particular job, like engraving, our mounting holes, and the contour of the sign. You can also see the tabs produced. They are displayed here. So the list of our toolpaths is arranged in the order as we set it up. So the first operation will be engraving, then pocketing, and then profiling. But unfortunately, the list is not informative about, for example, about the tools we're using. So if you want to rename the toolpaths, you can right-click on its name, click on Rename, and now you can rename it to contain information you want. So we'll be using 6.35 millimeter V-groove cutter. For the pocket, we'll be using 6 millimeter flat end. And for the profile, we'll also be using 6 millimeter flat end cutter. You can also change the position of the operations by moving operations up or down. This will only become relevant when you want to export the multiple toolpaths in a single file. So therefore, the definition of the list will become very important. Now our toolpaths are generated. We are ready to export them into G-code files.